We're asked to find y prime, or dy dx, of this function right here. So we also have to assume that y is a function of x. Okay, so that's this piece right here. So what I'm going to do is I'm going to differentiate this guy. Just like this. Take d dx of x squared and add it to d dx of y squared. And that's going to be equal to d dx of 1. Well, d dx of 1 is 0. d dx of x squared is 2x. This is the guy right here that's complicated, because y is a function of x, and we're taking the derivative with respect to x, so we need to use the chain rule. So this piece right here is going to become dy dx times dy of y squared, like that. So this gives us 2x plus dy dx. I don't know what that guy is yet. That's what we're trying to find. We're going to solve for that. And then dy of y squared is 2y. So let me move the 2x over. Let me divide everything by 2y. And that'll give me negative x over y. Now when y is 0, okay, because we just divided by y, if y is 0, then we also know that x, the x value here, would be 0. So we have this strange thing going on. You may want to take a look to see what this graph looks like. Actually, let me draw it out for you. This graph looks like a circle of radius 1. Okay, and what we've really done here is this is implicit differentiation. Okay, and so that's used when it's difficult to solve for one variable in terms of the other variable without having to set up multiple equations. Like, we can't get y by itself here unless we say y is equal to plus or minus the square root of something, and then that, of course, is defining two different functions. So y is some function of x here. Okay, the graph is clearly not a function. However, what we're saying is that y changes as x changes. Okay, there's a relationship here between them. Okay, but this clearly is not a function. And so, well, we've really got two different functions, a function up top here and a function down here at the bottom. Okay, and so if we take a look at this, if we grab anywhere, like here, if we grab an x value, well, when x is 1, oops, I should actually test that. This has a radius of 1, so when x is 1, the y value associated with that is 0. And so the slope here is negative 1 over 0, and that's not defined, which should be clear because your tangent line would be vertical. If we grabbed a different point, let's say we grabbed, I don't know, this point here, this is at the point 0, 1. So here's our x, here's our y. We plug those in there, we get a slope of 0. Now, of course, there's another guy down here that also has a slope of 0. Now, if we pick a point, let's say we pick an x value here, I don't know, x equals 1/2, and we solve for the y value, there's two different y values that come out. A guy up here and a guy down here. Just like here, positive 1 and negative 1 both work for y when x is 0. So when x is 0, these guys are both solutions to this equation. So what will happen here is we'll get two different y values, and we plug their x and their y values into this, we'll get the two different slopes.